I'm going to start today by playing a piece of the lesson from last time to try to get us thinking about a point that I made towards the end of last lesson. If I eat one of these pieces, then I've eaten 1/4 of the cake. So think about it before we had 5/11. So you had 5 out of 11. So that'd mean I cut the cake into 11 pieces and I ate 5 of them. But if I eat one piece out of the 4, then 1/4 of the cake is gone and 3/4 of the cake is left. Now if I eat 2 out of the 4 pieces, I've eaten 2/4 of the cake. Now think about that for a second. Take a look at the picture. That's actually the same as 1/2 of the cake, isn't it? If I had just cut it in half and eaten half of it. So as you can see, I can represent the same piece of information that a fraction represents in multiple ways. In other words, each fraction has many ways that you could write it. As with anything, when there's many ways to write something, I want to try to find the simplest way to write it. And that's the idea of simplifying fractions. To understand how to simplify fractions, we got to talk about something called factors first. And I'll start off with the mathematical definition and then explain it from there. Okay, let's read this together because I want to point out some things as I read this. If m times n, so m and n are two numbers, equals c, another number, then both m and n are factors of the number c. Okay, so what this basically means is that if you can multiply one number by another number to get some third number, then those two numbers you multiplied are factors. For example, 2 is a factor of 10 since 2 times 5 is 10. That also means that 5 is a factor of 10. Makes sense? So if I can find something that I can multiply it by to get the next number, then that means it's a factor. Another way of thinking about this is look at 2 and 5. If you take 10 divided by 2, you get a whole number. If you take 10 divided by 5, you get a whole number. So if I can divide a number by that number to get a whole number, then it's a factor. Okay, we're going to look at this closely because the more you talk about it, you start saying numbers so many times it can almost be confusing. What if I asked you what all of the factors of 10 are? This is the exact same thing as asking what numbers can you multiply to get 10. Think about it for a second. You can multiply 1 times 10. You can multiply 2 times 5. And we're talking about whole numbers. Can you multiply 3 by anything to get 10? Well, no. And in fact, if you divide 10 by 3, you'll get a decimal. So actually, all the factors are 1, 2, 5, and 10. Okay, so this is hopefully starting to make a little bit of sense here. If I can multiply two numbers, then I can end up with having factors of the original number. Okay. What if I wanted to find all factors of, say, 18? Okay, you start thinking of things that you can multiply to get 18. 1 and 18 should be the first ones that come to your mind. But you can also multiply 2 times 9 and 3 times 6. The best way to, if you're trying to find all the factors, which we're really not going to do, I may ask you 1 or 2 questions about it, but the best way to find all the factors is to just start dividing by the numbers less than 10. So divide 18 by 2, does it work? Divide 18 by 3, does it work? But the big idea here is just understanding what a factor is and being able to think of at least a couple of factors. Okay, what about 39? Well, this one's a little bit harder. 1 and 39 are definitely factors. That's always going to be true. 1 and the number of factors. Okay, so I start thinking, well, is 2 a factor? Well, 39 divided by 2 is not a whole number, so no. Is 3 a factor? 39 divided by 3 is 13, so both 3 and 13 are factors. Is 4 a factor? Well, 39 divided by 4 is a decimal. Is 5 a factor? 39 divided by 5, decimal, so it's not a factor. And you can keep going and see that these are the only factors of 39. Again, the big idea I want you to understand is to at least be able to think of some factors. And there's actually a lot of tricks for these. There's actually a huge list for everything, but there's a few common ones that I use most often. First of all, if a number is even, then 2 is a factor. 18 is even, so that means 2 is a factor. As soon as I know 2 is a factor, I can divide the number by 2 and find another factor. If a number ends in 0, then 10 is a factor. Now think about it, if 10's a factor, then that means most likely 2 and 5 are factors as well. Okay? This is a weird one, but it's actually really helpful. If you add up the digits of the number, and that's divisible by 3, then 3 is a factor. And if you look up here at 39, 3 plus 9 is 12, and 12 is divisible by 3. In other words, you can divide 12 by 3 and get a whole number. So that means that 3 is a factor of 39. That's a weird little trick that actually works. And there's a few others like that, but I would say that I use these the most often. Okay, let's look at the number 150. Automatically, I see it ends in 0, so 10 is a factor. So I would divide 150 by 10 to find another factor, so 15 is a factor. So that means 10 times 15 is 150, so 10 and 15 are factors. All right, now think about it. 15 is 3 times 5. That tells me that 3 and 5 are also factors. Okay. If I divide 150 by 3, I get 50. So that means 50 is a factor. If I divide 150 by 5, I get 30. So that means that 30 is a factor. Okay, 2 is a factor. How do I automatically know that? 150 is an even number. 150 divided by 2 is a 75. So that means 75 is a factor. 75 is 3 times 25. So that means both 25 and 3 are factors. Now we already knew 3 was a factor from before, but 25 is a new one. Okay, 150 divided by 25 is 6. So you see how I can just start logically going through the list, and that little list of tricks before helped me. All right, and here's actually all the factors of 150. So it means I can take this number and it will cleanly divide 150, any number on this list. So 150 divided by 3 is going to be a whole number. 150 divided by 10 is a whole number. Again, this is a huge list. I don't expect you to be able to just list all these out all the time. It's more work than's necessary. And a lot of books and instructors make a big deal out of finding all the factors. I want you to know what a factor is and be able to find at least a couple of them, and you'll see why soon. And one of the biggest things that you'll see people talk about is the idea of the greatest common factor. I want you, and I think to understand fractions, this is all you really need to know, is what it is. The greatest common factor is the biggest factor that both numbers share. And people have done a lot of work on how to find these. So I'll just show you an idea just so you understand the concept. What if I said find the greatest common factor of 25 and 110? One way I could do this is just by listing all the factors of both of these numbers. So 25 is 1, 5, and 25. And 110 is all these numbers. Okay, and obviously I'm not showing all the work I did to find these. The only number that they share, the biggest number they share, is this 5. So this means the greatest common factor is 5. Now, really, all I need to know is any factors that they share other than 1. In this case, the only one is 5, other than 1, and you'll see why. But you'll see a lot of people talk about the greatest common factor, so you should know what it is, but you don't actually need it to simplify fractions. Remember, that's our goal, is to simplify fractions. So again, there's other methods here, and you can look them up if you would like or ask me about them. But when simplifying fractions, you have to be able to identify factors that are shared by the numerator and the denominator. Okay? So I want you to understand what's a factor. And I want you to be able to find factors that two numbers share, not necessarily the biggest one, but any two.